So, we will continue the solved examples based on the chain rule from the topic differentiation. In that, the third example is y is equal to log of x to the base 5 to the base 3. So let y is equal to the given function. Then we will use a change of base law here to change the base of this log of x to the base 5. We have the formula log of beta to the base alpha is equal to log of beta to the base to the new base upon log of alpha to the new base. I have not written the base here because I am considering that the base is e. So this can be written as like this, and then a log x upon log 5 to the base 3. Now in this case, log of something, log of a by b is log of a minus log of b. You can use that formula and separate this logarithm. So you get log of log x to the base 3 minus log of log 5 to the base 3. Now again we will change base here. Log of beta to the base 3 can be written as log of beta to the base e upon log of 3 to the base e. So once after completing that, writing this, we will differentiate with respect to x, taking different derivative on both the sides. Dy by dx is equal to d by dx of the given function. Now log 3 is constant, so 1 upon log 3 I can take outside, and then d by dx of log x, and similarly d by dx of log 5 to the base 3. But here there is no variable, it is a constant with respect to this x, so its derivative becomes 0. And log x, so log of f of x, I will treat the function as log of f of x. Its derivative is 1 upon f of x into f dash of x. So 1 upon f of x into f dash of x means log of x, its derivative is 1 upon x. So multiply it, taking together, you will get 1 upon x log 3 is the derivative of the given function. The second problem, y is equal to log of in bracket e raised to 3x into 3x minus 4 raised to 2 by 3 upon cube root of 2x plus 5. Whenever there is a log outside the completed function, we will use the properties of the logarithm. Log of something is equal to log of this. Then this cube root of 3 can be written as 2x plus 5 raised to 1 upon 3. That is simplified by from this step to this step. Then log of a by b can be written as log of a minus log of b. We use the log property of the log. Then here is a product of two functions, so again we use the property of log. Log of a into b is log of a plus log of b, and then the final log of index. That index is we can take outside the or in front of the log. Log of e raised to 3x can be written as 3x log e, but log e is 1, so we will not write it, so only remaining is 3x. Now 2 by 3 we can take outside, so 2 by 3 log of 3x minus 4. Similarly we can take 1 by 3 log of x raised to n is n times log x. We use that property. So differentiate this equation with respect to x. So derivative of 3x, derivative of 2 by 3 log of 3x minus 4, and derivative of 1 upon 3 log of 2x plus 5. So derivative of 3x is 3. Derivative of log of f of x is 1 upon f of x into f dash of x. So 1 upon 3x minus 4 into d by dx of 3x minus 4. Similarly, log of 2x plus 5, its derivative is log of f of x is 1 upon f of x. So 1 upon 2x plus 5 into d by dx of 2x plus 5. So 3 plus 2 by 3 into 1 upon 3x minus 4 minus 1 upon 3 into 1 upon 2x plus 5 into derivative of 2x plus 5 is 2. So simplify it, 3 plus 2 upon this 3 will get cancelled, and will 3x minus 4, and here 2 upon 3 times 2x plus 5. Differentiate with respect to x, y is equal to log of square root of 1 minus cos 3x upon 2 and 1 plus cos 3x upon 2. We have to simplify it. Instead of finding the direct derivative, uh, we will simplify it. How to simplify? 1 minus cos 2 theta is 2 sin square theta, and 1 plus cos 2 theta is 2 cos square theta. Okay, but here the angles are not double angles, so 1 minus cos 3x upon 2 can be written as 2 sin square 3x by 2 upon 2. So 1 minus cos 3x by 2 can be written as 2 sin square 3x by 4. 1 plus cos 3x upon 2 can be written as 2 cos square 3x by 4 using the half angle formula. So 2 gets cancelled, and sin square upon cos square is tan square. That root also will get cancelled. Log of tan 3x by 4 will remain. So differentiate with respect to x, d by dx of this. So I will treat it as log of f of x. So derivative of log of f of x is 1 upon f of x into f dash of x. So d by dx of tan 3x by 4. Again, I will use tan of f of x. Derivative of tan of f of x is sec square f of x into f dash of x. So sec square f of x into d by dx of f of x. So d by dx of f of x means d by dx of 3x by 4. So what 3x by 4, I can write it as cos 3x upon sin 3x by 4. And this sec square 3x by 4, I can write it as 1 upon cos square 3x by 4 into d by dx of 3x by 4 is 3 by 4, since derivative of x is 1. Now here is 1 cos and here there are 2 cos. So 1 cos will get cancelled. So 1 cos will remain. So 3 upon 2 into, I will break this 4 into as 2 into 2. So 1, 2 is, I will write it with sin 3x by 4 into cos 3x by 4. So that I can use the sin double angle formula. Sin 2 theta is equal to 2 sin theta cos theta. So 2 sin 2 times 3x by 4 is 3x upon 2. So this is the derivative of the given function. 3 upon 2 times cosec 3x by 2. Next example, y is equal to log of x plus root x square plus a square upon square root x square plus a square minus x. Consider that we will rationalize the this function. We will rationalizing denominator, so that we multiply the conjugate by its conjugate of the denominator. Root x square plus a square minus 6, its conjugate is root x square plus a square plus 6. Multiply, divide by it, you get bracket square. Numerator, in numerator, root x square plus a square plus x bracket square upon denominator a minus b, a plus b is a square minus b square. So this square root will get cancelled, and x square plus a square minus x square. So x square again gets cancelled, and you will get a square. So this is the remaining part. Again, I can use the law property of logarithm. Log of a by b can be written as log of a minus log of b. So using that, y is equal to 2 times log of this minus log of a square. Now we will differentiate this function with respect to x, because now hence further we cannot simplify it. So solve this. Do d by dx of 2 times log of x square plus a square plus x minus log of a square. So d by dx of the first part minus d by dx of the second part. But log of a square is a constant, so its derivative is 0. So we have to find the derivative of only this function, log of f of x. So log of f of x is 1 upon f of x into f dash of x. So 1 upon f of x into f dash of x. F dash of x means d by dx of f of x. D by dx of square root of x square plus a square plus x. So again, d by dx of root f of x, its derivative is 1 upon 2 root f of x into f dash of x. D by dx of x square plus a square plus derivative of x is 1. So in next step, this derivative of x square plus a square is 2x plus 0 and is 2x. So then take the 2 will get cancelled, and you will get x upon root x square plus a square plus 1. Then take their LCM. You will get x plus root x square plus a square upon root x square plus a square. So this here 2 upon something and here something upon this. So this will give both will get cancelled and you will get 2 upon root x square plus a square. Now this differentiate with respect to x, y is equal to 4 raised to log of sin x to the base 2 plus 9 raised to log of cos x to the base 3. I can write this 4 as 2 square and this 3 as 9 as 3 square. Then again using the laws of logarithm index, laws of exponent, laws of indices, I can write this as it is, and in that again I will write like this. So here a raised to log of f of x to the base a is same as f of x. I will use this property in both the steps. Then I can directly write it as sine square x and cos square x. But sine square theta plus cos square theta is 1. So its value is 1. So the given function, instead of writing all this function, I will write it as y is equal to 1 only and differentiate with respect to x. So I get y dy by dx as dy by dx of 1 and it is comes out to be 0. So this is the derivative of the given function. So look at this function. It is so too much big function and its derivative is 0. And from where we have started the derivative? Only from this step. In one step only the derivative gets 0. Before that we have just simplified the function. So derivative is not as much difficult, but it needs a practice to deal with the functions. The third example, y is equal to a raised to log of cot x to the base a. Here is also the simplest function. Just simplify it. A raised to log of cot x to the base a. Their bases are same, so we will use the same law again. I will write it as f of x. So instead of writing a raised to log of cot x to the base a, I will simply write it as cot x. So I get a raised to cot x. So a raised to f of x, and derivative of a raised to f of x is a raised to f of x log of a into d by dx of f of x. Okay, and d by dx of f of x is d by dx of cot x is minus cos x square x. So the derivative is minus cos x square x into a raised to cot x into log a. The fourth example, what is given? F of x is equal to root 7 g of x minus 3. G of 3 is 4, g dash at 3 is 5, and f dash at 3 is, we have to find out. What is given? F of x is equal to root 7 g of x minus 3. Let us differentiate this function with respect to x. So derivative of f of x is f dash of x, and derivative of this means root of something. Root f of x is 1 upon root f, 2 root f of x into f dash of x. Use that chain rule. And d by dx of 7 g of x minus 3. 7 is as it is. G of x, its derivative is g dash at x, and minus 3 is constant. Its derivative is 0. So you get 7 times g dash of x upon 2 times root 7 g of x minus 3. Now whatever values they have given, they are all at x is equal to 3. So we will put x is equal to 3 in the given equation. You get f dash at 3 is equal to 7 times g dash at 3 upon 2 times root 7g of 3 minus 3. F dash at 3 is equal to 7 into 5 upon 2 root 7 into 4 minus 3. Because g of 3 is given 4 and g dash at 3 is given 5. Simplify. You will get the value of the derivative of the function at x is equal to 3. The fifth example, if capital F of x is equal to capital G of 3g of f 5g of x, g of 0 is 0, g dash at 0 is 3, you have to find f dash at 0. What is given? F of x is equal to g of 3g of 5g of x. Composite. This is just a composite function. Composite function of so many functions. So differentiate. F dash of x is equal to d by dx of this function. So you have to use the composite function. Firstly, we have to take the derivative of this g. It is g dash of something into, you have to differentiate this function with respect to x. Then in second step, we have to take that derivative of this g, and then we will into derivative of 5g of x. Then 5 take common, and then derivative of g of x is g dash of x. Now what are the values they have given? We have to put them over here. So for x is equal to 0, we will put x is equal to 0 everywhere. G dash at 0 is given 3. G of 0 is given 0. So the value is 0. And once the value is 0, so what you get? G of 0 into 0 is 0. And G dash of 0 is 3. So 3 into 3 into 3. So it becomes 15 into 3 into 3 into 3 is 405. Now there is one activity. What is that activity? Uh, Select the appropriate hint from the hint basket and fill in the blank space in the following paragraph. So here f of x is equal to the given function. Differentiate this f of x is given sin x. F of x is sin x and g of x is log x. Now f of g of x, we have to take these functions from this. F of g of x. So what you get? G of x is log x. So here is f of log x. F of log x. But what is f? F is sin x. So here is sin of log x. So this is the first blank space. Then g of f of x. G of f, what is f of x? F of x is sin x, and g of x is log x. So it is log of g of x, log of sin x. This is the second blank space. Then the next one is the derivative of f of g of x with respect to x in terms of f and g. Derivative of f of g of x with respect to x. F of g of x. So 1 sin of log x. Its derivative is, what is the derivative of this? Its derivative is sin of f of x is 1 upon f of x. So 1 upon log x into sin x. The derivative is cos x. So cos x upon log of x. So the derivative with respect to x. So the derivative of sin of log x is cos of log x upon x. So this is our third blank space. Now moving further, this is first blank place, this is second blank space, this is third blank space, this is fourth blank space, and this is fifth blank. Now d by dx of f of g of x. What is d by dx of f of g of x? F of g of x, its derivative is f of f dash of g of x into d by dx of g of x. So this is the fourth blank space. Now d by dx of f of g of x at x is equal to 1. So f dash f g of x into g dash of x at x is equal to 1. So we have to actually find the derivative of this function. So the value of this derivative at x is equal to 1. So derivative is this 1. This is the fifth blank space. Now the derivative of g of f of x. Derivative of g of f of x with respect to x in terms of f and g. Again, we use the same, just like this f of g of x. Its derivative is given by g of f of x. G of f of x means log of sin x, and log of sin x, its derivative is log of sin x into cos x. Log of sin x into cos x. So its derivative is given by g dash of f of x into f dash of x. G dash of f of x into f dash of x. This is the sixth blank space. Then the next one, d by dx of g of f of x. D by dx of g of f of x means log of sin of x. Its derivative is log of cos log 1 upon sin x into cos x is given by cot x. So this is the seventh blank space, and the d by dx of g of this will be the it is for you. You have to find it. I will not going to tell this. Okay, and so this is all about the solved examples on the chain rule.